Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Intramolecular aldol condensation. The starting material is a ketoaldehyde, CH3, is equal to O, CH2, 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 C, is equal to O, H, hept 6-1-1 al, i.e. 6-oxoheptanyl. Under basic conditions, O with heat, an intramolecular aldol condensation occurs. Moving on to the next step. The aldehyde end, ChO, has no alpha-H on its carbonyl carbon since it is terminal. However, the methyl ketone end, CH3, CO, has alpha-H on the CH2 adjacent to the ketone and the CH3 group. The aldehyde carbon itself is the electrophilic carbonyl. Moving on to the next step. Base abstracts an alpha proton from the carbon alpha to the ketone. The most favorable intramolecular cyclization considers ring size. The alpha carbon of the ketone, the CH2 directly attached to C is equal to O of ketone, i.e. C2, attacking the aldehyde carbonyl, C7, would form a 6-membered transition state ring. Let us count. C2, C3, C4, C5, C6, C7 is equal to 6 atoms in the ring forming a 5-membered carbocycle, 5 carbons in ring with O outside. Wait, let us recount the chain. C1, CH3, C2, C is equal to O, C3, CH2, C4, CH2, C5, CH2, C6, CH2, C7, C is equal to O, H. Alpha to the ketone at C2, C1, CH3, and C3. Alpha to aldehyde at C7, C6. And for the final step. If enolate forms at C6, alpha to aldehyde C7, and attacks ketone C2, ring would contain C2, C3, C4, C5, C6 is equal to 5-membered ring. This gives a cyclopentane ring. After aldol addition and dehydration, a cyclopentane or cyclopentanyl product forms. Enolate at C6 attacks ketone carbonyl C2. The aldol product after cyclization gives a 5-membered ring with OH C2 and the CH3 group exocyclic. After dehydration, elimination of water, the double bond forms between C2 and C3 or C1, C2, placing the C is equal to C conjugated with the exocyclic acetyl group, CH3CO. This gives 1-cyclopent 1N1-vial, ethan 1-1, i.e. 1-acetylcyclopent 1Na, which matches option B. A cyclopentanyl ring with the C is equal to O, CH3 group at the vinylic position, C1 of the double bond, giving an enone system with extended conjugation. A cyclohept 2N1-1 would require a 7-membered ring, which is less favorable than 5-membered ring formation. C requires a different connectivity and does not reflect simple intramolecular aldol. D has the acetyl group at a saturated sp3 carbon, which would not be the thermodynamically favored conjugated product after dehydration. The 5-EXO trig cyclization, or equivalently the formation of the 5-membered ring with conjugated enone, at 73% yield is consistent with intramolecular aldol condensation giving the conjugated cyclopentanyl ketone, option B. Therefore, the correct answer is B. Therefore, the correct answer is option B.